everyone, and welcome back to the channel. In this video I'm going to show you how to find prime numbers. Well, how to write program to find prime numbers using Python. So start simple. I'm going to write two separate programs, two different functions rather. Alright, so we write the first one and then we improve it in the second one. And also I'll write a program to check the time so that we can compare which one is faster. Alright, so firstly, what is a prime number? A prime number is any number that has no other divisors other than 1 and itself. Alright, so it means that number cannot be divided by any other number other than 1 and itself. Okay, so examples are 2, 3, 5, I think 7, I'm not sure, is there 9? No, 11, yeah. So 2, by the way, is the only prime number that is an even number also. Every other prime number are odd numbers. So to get started, let's import the math function. All right, so I need to import the math function, or the math library, sorry. So it's from there we're going to be using the square root function. So I'll say def is prime, and we pass a parameter of number to it. So we check if the number is less than or equal to 1. All right, so by the way, I think I should redefine what a prime number is. A prime number is a whole number greater than 1. All right, I did not specify that. The number must be greater than 1. Any number that is 1 or less than 1 is not a prime number. All right, so any whole number greater than 1 that can only be divided by 1 and itself, so is a prime number. So we are checking if the number is less than 1 or equal to 1. Of course, it is not prime, so we return false. Good. Then we also check. Remember I said 2 is the only even number that is also prime. So we want to check if the number that we pass to the function, if it is 2. All right. So what do? Return true. All right, so then we want to check for every even number. If the number is an even number, so num mod 2 equal to 0. All right, so return false. So 2 is the only even number that is prime. Every other even number are not prime. Then we want to create our square root number, right? So I say square root num should be equal to math dot square root. All right, then we'll pass num to it. To be on the safer side, let's typecast it to an integer. All right, so I'll typecast it to an integer, and after we do that, we want to check and make sure we check for only odd numbers. So I'll say for I in range starting from 3 and stopping at square root num. Of course, we need to offset it by 1, and then we want to take every 2 steps. All right, so we want to jump every even number. We don't want to waste our time checking for even numbers. We want to skip them. So it starts at 3, it will jump to 5, 7, and so on. But remember, not all odd numbers are also prime. So we want to check for any other number, which in this case will be an odd number, right? So any other number, right, that can be divided by another number other than 1 and itself, right? So we say for num modulus I equal to 0. So if the number can be divided by another number, then return false. That number is not that number is not an odd number. All right, oh sorry, I'll say if, not for. So if, it should be an if. Then the last thing we're going to do is return true. So after we've checked for all these conditions, then the number is indeed true. So I'll do for I in range. All right, range, let's do 10 All right, so I'll say print f string. I want to check for all the numbers, right? So I'll say I should be equal to is prime. Then we'll pass I to it. So any number that from 0 to 10, which will stop at 9, any number from 0 to 9 that is a prime number, we get true. Any number that is not, we get false. So when you run the program now, you see starting from 0, 0 is false because 0 is less than 1. 1 is false because 1 is 1, all right? Then 2 is true. 3 is also true. And so on up to 9. 9 is false. 9 is not a prime number, right? So the second one we're going to check is actually more optimized. So I'll say, or should I say more efficient? Let me use that word. More efficient. Okay, so I'll say def is prime. I'll say 2 is prime 2. We also pass a number to it. And then we check, as before, if num is less than 1. Right? If num is less than or equal to 1, of course, we return false. Right? Then we also want to check if num, okay, less than or equal to 3. So we want to check for 2 and 3 in this case. So if num less than or equal to 3, return true. All right, so this second if we check for 2 and 3. The first one checks for 1 and every number less than 1, so it returns false. The second if statement checks for 2 and 3. All right, or if you want to be very specific, you say if num is equal to 2, all right, it's equal to 3, or num is equal to 2. Right, let's check for 2 before 3. So I'll do 2. So you can specify it this way if it will help you understand it better. Then last but not least, we also want to check for every number that is an even number. Remember, 2 is the only even number that is prime. Every other even number are not prime. So if num mod 2 equals 0, or any other number that can be divided by 3, that is divisible by 3, all right, or num mod 3 is equal to 0, okay, return false. All right, so now we're going to use our loop, but this time around, instead of us to start from 3, right, we're going to simply start from 5. Okay, so I'll say I should be equal to 5. All right, then we say while what do I do? Okay, while I multiplied by I is less than or equal to num. Okay, we want to check if num modulus I is equal to 0. All right, or num modulus, we put it inside parentheses, I plus 2, okay, equal to 0. Let me put a space here. Equal to 0. What do? Return false. Okay, then we do I. We want to be moving at every 6 steps. So you see this one is actually faster. So I plus equal 6. This one is much more faster than the previous one. So we return true. All right, so after we check for every condition, now we can return true. If it did not return false for any of these conditions, then it can now return true. Well, something is rough here, right? Mod 2 equal to 0. All right, I should put 0 there. Good. So now we can also check. Let me pause this. All right, I'll comment out this. I'll comment out the first one. Right, so now when you run it, you see nothing. Now we'll run the second one. So for I in range, let's do it to 20 this time around. So I'll say print, using an F string, we say print I should be equal to is prime 2. All right, is prime 2. We pass I to it, and then when you run the program, you should see, so 0 is false, 1 is false, and of course up to 19. All right, 19 is true. So we started from, let me explain the logic again. We eliminated any number less than or equal to 1, of course. We check if the number is 2 or 3, it should return true. All right, then we check starting from 5. Okay, we also check for all even numbers and any number that is divisible by 3, so we return false. So for our loop, we check starting from 5, all right, and test I and I plus 2. If any number is divisible by I, or the number is divisible by I plus 2, all right, it should be false. Okay, what we are simply doing is we are checking if there is any number that is divisible by another number other than 1 and itself. That is what this while loop is doing, and we are moving at the rate of 6 steps. So this is much more faster than the square root one we did in the first instance. So let's even go ahead and check for the performance. All right, so I'll import time. Okay, so now importing time, I'll do, what should I call the function? I'll call it let me also comment out this one. All right, so I'll comment out this one too. Good. So when I run it, I say nothing. Now create a function and call it benchmark. All right, so benchmark will take 2 parameters. We want a callback function, so I'll say callback, and then we want the number. All right, we want the number that we want both of them to check, so none. Then we want to create the start time, so I'll say start should be equal to time dot time. All right, so we say for I in range of n of number, all right, of norm. All right, for I in range of norm, we want to call back, so we want to pass I to the callback function. All right, we want to pass I to the callback function, and then when we are done running the loop, we create another variable called end. So I'll call it end should be equal to time dot time. All right, so when it starts, we take the time at the point where it starts, and then after we go through the loop and we are done with the loop, the time immediately after finishing the loop will be the end time. All right, now we want to return the difference, so I'll say time difference, time div should be equal to end minus start. All right, I've got it in caps lock. So time difference should be end minus start. Then we'll return time difference multiplied by 1 million microseconds. All right, so 1 million microseconds. Good. So now when we are done, I'll simply come out here and say the time for square root time is prime. All right, time is prime 1. All right, should be no, time is prime 1 is a variable, right? We'll say benchmark we'll give it is prime, comma, and then we'll pass, let me create a variable, I'll call it n should be equal to 1000. All right, so we now pass n to it, and then I do the same thing, so is prime 2. All right, so I'll say is prime 2. You know what, let's change this is prime, let's change the name to is prime 2. All right, so I'll change all occurrences, so we'll say 1. Now we've changed the name everywhere to is prime 1, then is prime 2. Then when we are done checking it, we want to check the performance. All right, so I'll do print performance results. All right, print performance results. And then for the is prime, I'll say print f string is prime 1 is prime 1 is equal to, so I'll say time is prime 1, and then we want to round it up to 2 decimal places. All right, so I'll say dot 2f. I think that will be microseconds, nanoseconds. All right, so I'll just duplicate this and I'll say is prime 2. All right, good. So what we are doing, I created a function, call it benchmark. It takes, so I created a function, call it benchmark. Benchmark takes a callback function and the number of times we want it to test the callback function to test. So now we come outside and then we test each of the function and we see the time it takes them to run. All right, so now when I run the program, you're going to see is prime 1 runs at 229 microseconds, and this one is prime 2 runs at 199. So you see is prime 2 is actually faster. And when we even increase the number, all right, so 10,000, you're going to see that is prime 2 is still faster, and the higher we increase it, the more faster is prime 2 is going to become. All right, so that's all for this video. If you find it helpful, please make sure to like and subscribe to like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching, and bye for now.